In the previous video, in reference to the product rule of exponent, that rule stated that we have to add, that rule stated that we have to add the exponent, but only if their base are the same. The quotient rule states that we have to subtract the exponent. So if you have a problem that looks like this, we can subtract the exponents just as long as the base are the same. So what do I mean by the base? Well, look at x to the fifth and x to the third underneath it. The x represent the base for both the top numerator and the bottom denominator. The same can be said about the y variables, whereas y to the fourth in the numerator and y to the second in the denominator, we will have to subtract their exponent. So let's dissect this problem. The quotient rule states that if you have a division problem that has the same base and the numerator and denominator have exponents, then you must subtract their exponents. As I stated, x and y are our base in this problem. They are both the same at the top, the numerator, and at the bottom, the denominator. Now, as it pertains to x, we will subtract the exponents, 5 minus 3. So now our x will become x to the second power. Because 5 minus 3 equals 2. And we will apply the same technique for the y variable. So now our y variable is y to the second power. So let's rewrite this problem. We now have 13 x to the second power times y to the second divided by 12. So we can simplify this problem even more by dividing 13 divided by 12, in which we will get 1.08 and a whole bunch of threes. So 13 divided by 12, we will get 1.08. And we have a repeating amount of threes. In other words, a lot of three, 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 three. So remember what I said in one of my other videos, when you have something like that, then you just put a bar on top of that just to just to be informed that this 3 is repeating. So now our new rewriting the problem, this is what we get. X to the second and y to the second. And this is your answer. We could have also attacked this problem in a different way. Remember that anything raised to an exponent represents multiplying that by the number it is raised. Like, for example, you have x to the fifth can be written as x times x times x times x, multiplying x 5 times, divided by x to the third, which can be written as x times x times x. Let me write it down right here so you understand what I'm talking about. So right here, let me go ahead and circle that. This could also be written as x times x times x times x times x over x times x times x. Now, we could have applied the same we could have got the same answer from just going by the quotient rule, which is subtracting the exponents. We could also did this. We could have scratched that out. These three. One, one, two, three. And what do you have left? You have two. Two x's. Two x's means x squared. Okay. Same thing. Same thing for y to the fourth over y to the second. Y times y over y squared. We have two down here. So let's cross out two up here. And what do we have left? We have two. Y times y is the same thing as y squared. So rewriting these two, rewriting this whole problem, right? Rewriting this whole problem. We already know that 13 divided by 12 give us 1 point. I forgot the exact number, but I just put 1.08 x squared y squared, and here's our answer. So here's a bit more of a challenge. So we have 5 to the second power times a to the third times x to the fifth times y to the fourth, all divided by 5 to the fifth times a to the seventh times x to the eighth and times y to the seventh. The good thing about this problem is the fact that they all have the same base. So we can apply the exponent rule to each individual base that replicate each other in the numerator and denominator. Let's do one base at a time, starting with 5 to the second power over 5 to the fifth power. Let's rewrite the base as the multiple of its exponents. That way you can see how to approach a problem like this and not, and you're not, if you're not too sure or fond of the quotient rule. So we will write 5 to the second as multiplying 5 two times. So I'm going to do the 5 base first. So 5 times 5. Okay. And then up underneath, we have 5, 5 times 5 times 5 times 5 times 5. Let me straighten that out a little bit because it look a little sloppy. So we would apply that same technique as we did before. So only this time we have 2 at the top, so we're going to knock off 2 at the bottom. So how many 3's left we have at the bottom? We had 3. I'm sorry, how many 5's left we have at the bottom? We have 3 5's. So this here will become 1 over 5 to the third. Okay. Let's do the next base. So I'm gonna try to squeeze it all here. And that's that one. So the next base will be a cubed divided by a to the seventh. So that'll be a times a times A over A times A 6 and one more A. That'll be 7. Same thing. 1, 2, 3. 1, 2, 3. How many A's I have at the bottom? 1, 2, 3, 4. So that would be 1 over A to the 4th power. So let me go ahead and rewrite these two that I have so far over here. So I'm going to use this space right here to add all of the bases inside. So I'm going to write down 1, 5 cubed and 1 A to the 4. So now let's go to the next base. And we can do this, and we'll do this right up under here. So x times x times x, 1, 2, 3, 4, times x, which I have 5 there. 2. All right, so that's 8 x's on the bottom. 5 x's at the top, 8 at the bottom. So we already know 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 3 left at the bottom. So we just add 1 over x cubed. There you go, you have that one. So now we're here. Y, let's go ahead and block that off. Y times Y times Y times Y, and then 7y. Okay, again, 1, 2, 3, 4. 1, 2, 3, 4. Let's bring it. So we have 3. So we have 3 y's left. So let's write it up under there too. 1 over y cubed. So we can also write, let's go ahead and get everything that we got right over here. 1, hold on, let's see. Put it in the same color as I got each one. 1 x cubed, 1 over y cubed. Okay, so look at the numerator. We have all ones, right? So basically 1 times 1 times 1 is going to equal 1. So let's go ahead and write the official answer right up underneath here. 1 over 5 cubed, a to the 4, x to the 3rd, and y cubed. Now we can also simplify that 5. That 5 cubed, 5 times 5 times 5. Let me pull out a calculator. So 5 times 5 times 5, and that will give us 125. So we do it. This would be our official answer after simplifying it. So it'll be 125 a to the 4 x cubed y cubed, and there you have it. There you have it. There you have it. So the next up, we're gonna do the rules, the power rules of the exponent. The power rules of the exponents.